All right, here we are, learning about sine and cosine curves or waves. We're going to call these, so we've got a curve of the sine wave and of the cosine wave. And these are going to be also known as sinusoids. So just there you go, because the sine curve, if it's translated, can be exactly congruent and equal and identical to the cosine wave. And so we'll just refer to them as sinusoids, or really more frequently as sine waves. The sine waves would include both sine and cosine. So for functions y equals a times the sine of bx and y equals a times the cosine of bx, we're going to get our amplitude from a. And the reason it's going to be the absolute value of a, and it doesn't make a huge difference to be honest, but you always will see this as a positive number for amplitude, is because whether or not a is a positive or negative number, if it's positive, then it's going to be multiplying the sine wave's height. Remember, this is the output after you've done sine times bx, and that a will affect your y values. They'll either get much higher if it's greater than 1, or they'll get smaller if it's a fraction less than 1 or decimal. If it is a negative number, then it'll be reflected over the x-axis, but still by that absolute value of a. And so amplitude, again, is going to be the absolute value of a there. All right, next we have the period, and the period is going to be affected by 2 pi over your b value, or 360 degrees. Let's write that one in as well, or 360 degrees divided by your b value. And now why is that? Well, if b is 1, then the curve's occurring at just the exact same time that we're used to. But if you remember back in learning about chapter 4, we learned how the frequency can be either amped up or down, depending on, or maybe amped is not really the best term there, but can happen much faster or much slower depending on what is being multiplied by. Sorry, maybe I should fix the colors here. That blue should probably go with our A value here, while the red goes with the B value here. That if that number is high, then B value, then it's going to be happening all much more quickly, as many times more quickly as whatever B is. Or if it's going to spread it out, then that can happen as well. And so there we go. Hope that makes sense. And then so why can't they be 0? Why can't A be 0, or why can't B be 0? Well, think of it through it. If it's 0 times the cosine of bx, or 0 times the sine of bx, the whole thing just disappears and we end up with y equals 0. Likewise, if we had 0 times x with b being 0, then we're going to just get the cosine of 0, or the sine of 0, and so we'll get a more of a fixed point or a flat line rather than a wave. So, all right, I hope that helps.